We're going to now have our final speaker of the morning session, Chris Clemens from the University of North Carolina. He's a professor of astronomy. He's a former department chair, and since I'm a department chair now, that's a good thing. He's currently the dean, but we invited him anyway. His research specialty is white dwarf stars, but he also has an interest through his teaching in medieval scientific history, and that's what he's going to tell us about today. Medieval ideas of the multiverse.
I actually now work more on crushed up planets falling onto white dwarf stars, which is nice because NASA has more money than the NSF and planets are useful. I want to thank Steve Barr and the board of directors for organizing this conference, and it's an honor and a privilege for me to be here to talk about medieval ideas of the multiverse. This arises out of an interest I have as a member of our medieval and early modern studies program at UNC. And I teach a course called The Medieval Foundations of Modern Cosmology, and we use two popular books, and the two authors are here, so by chance, John Farrell's book and John Barrow's book. And a third of the course is about nothing, and so I tell the students they should at least be able to succeed in that part of the course. But I think the students probably would not say I'm the best lecturer in the college, but I do have the best digressions. I'm trying to stay off the digressions because I only have 25 minutes here, so I've written some of this down to keep me on task. Medieval multiverse sounds like an oxymoron if you adhere to a simplistic historical view of medieval scholasticism. In that view, obeisance to the authority of Aristotle is the central feature. And Aristotle was adamant that there could be no other world than ours. However, I don't take this simplistic view of medieval scholasticism, and I don't take it chiefly because of the work of the Catholic physicist, philosopher, and historian of science, Pierre Duhem, who we see here as a young man, I think in his academic regalia. If you don't know Duhem, I highly recommend him. He is underrated in almost every possible way. So I've put up here the equation no one knows his name is on, the 10-volume Système du Monde, which no one has read, and his philosophical work on the aim and structure of physical theory, which no one has understood. And I'm fairly serious about that last point. If you try to read that, please read his essay, The Physics of a Believer, first, because if you can capture his thought in those 10 pages, you will understand where he's going in this book. But it is work. Duhem's work in the history of science offers us a framework for understanding the emergence of science, beginning in about the 13th century, when the authority of Aristotle in physics and in philosophy collided with belief in the creative omnipotence of God. To most of the theologians in Paris, anything not forbidden by a logical contradiction was possible for God. But the arts faculty were teaching principles from Aristotle that appeared to limit God's creative power. And in about 1255 forward, the known works of Aristotle, all of them, were required reading for students in the university. So to address this rising conflict, which is not uncommon even in the modern university, instead of a dean stepping in, the bishop, and this is a conflict between faith and science, so we should remember that this conflict is not new. The science was Aristotle's, and the faith was the theologians of the 13th century. At any rate, Bishop Etienne Tempier of Paris on March 7th, 1277, advised by a panel of theologians, condemned some problematic theses of Aristotelian physics, and he threatened those who held or taught them with excommunication. And among these was the following: quod prima causa non posset plures mundos facere, that the first cause cannot make many worlds. So in this talk, following Pierre Duhem, and I should say not every historian subscribes to this view, and we'll say more about that at the end, I'm going to relate how this condemnation led immediately to the consideration of multiple worlds, and under an inversion of Aristotle's logic, which he sets forth in De Caelo, or On the Heavens, or sometimes called On the Heavens and the World. This led to a reconsideration of gravity as an attraction that varies with distance from the center of a world. By the 15th century, as I will show by the end, This line of thinking reached its most imaginative form in the works of Nicholas of Cusa, Bishop of Brixen, and a precursor to Copernicus. Nicholas of Cusa identified the sun and planets as other inhabited worlds and presented a surprisingly modern view of a universe without boundary or center. Because time is short, I'll have to ignore a lot of things, and so I'm going to focus on a single theme. So here's my plan, and here's my motivation. This is really an analogy between our situation and that of the medieval scientist. When we think about the multiverse today, and Dr. Barrow talked about this, one of the things we get from that is a better understanding and illumination of our fundamental but incomplete theories of particles and fields. And so those field and particle theories interact with the theory of inflation and provide maybe in the decay of a particle the energy needed to make this happen. The same thing was going on in the thread that I will follow. Gravity, the theory of gravity, is emerging over time and it grows from a simple law of falling bodies into a universal law regulating the interaction of all matter. This is a profound shift away from the Aristotelian realist view of gravity. So he saw gravity as the substantial form of elements like earth and water that causes them to seek a place at the center of the world. And we'll have to shift that to thinking of them as more like magnetism. In the medieval mind, a magnetic force required the iron to receive into itself a new quality, which was through some intermediary like the air, and thereby to move. So it was something added to the nature of the iron. So in his work on the heavens, which was translated from Arabic to Latin by Gerard of Cremona in the 11th century, Aristotle gives us several arguments for why there can't be more than one universe, or really, in his words, heavens and world. This slide shows a medieval representation of the heavens and world, and I think this one is from the Cosmographia of Petrus Appianus, 1539, but I could show you tens of pictures from books and manuscripts like this. If you think that this model for the universe has lost all hold on our imaginations today, then you have not tried to teach cosmology to undergraduate students. The 100% most common question when we talk about the universe, and especially if you're showing this picture, which you shouldn't, is what is it expanding into? And so this picture is responsible for that kind of misunderstanding of our modern models. For Aristotle, the realm here beyond the primum mobile, which is the outer circle, was not filled with a void, because a void was impossibility. There could be no void. There was not, that kind of nothing was not possible. And again, I recommend you, there are people who've written whole books on this subject, and one of them is here. You can read The Book of Nothing by Dr. Barrow if you want to know more about what is not there in the non-void beyond that outer ring. It was not a place at all. It was neither empty nor was it a place capable of receiving a body. And so I'm going to commit my first Aristotelian realist absurdity by putting a second heavens and world there. So Aristotle says if this second world has elements that are like our elements, not just in name but in their substance, then the element earth of this second world will seek a place at the center of this second world. But that would require it to move away from the center of our world. And that's against the nature of the element earth. So Aristotle says, for either we must refuse to admit the identical nature of simple bodies in the various universes, or admitting this, we must make the center and the extremity only one. There's a contradiction to have this other universe, or you don't really have the same element in it, and it's not a universe at all. So our reaction to this in our modern way of thinking is we would just have the body move to the center that's closest. But this really does not appreciate the degree to which Earth was a simple substance. Aristotle actually foresaw this argument because it had occurred in Platonic thought before. And he says, to postulate a difference of nature in the simple bodies, according as they are more or less distant from their proper places, is unreasonable. In other words, how could the nature of a heavy thing, literally a thing with the property gravitas, differ according to its separation from its natural place. That's not sensible in Aristotelian realism. And so he says this proposal that there's a second world is just absurd, because you can't change the nature of a body by where you place it with respect to these centers. St. Thomas Aquinas writes about this in his commentary on De Coelo, and he concurs with the opinion. He says, in fact, it does not seem that the greater or lesser distance that separates a thing from its place can determine a change in its nature. However, the angelic doctor does allow that the tendency to move more rapidly when closer to the natural place, that is, the acceleration of falling bodies, is reasonable, because he says a change in speed is a difference in magnitude and not the nature of motion. And therefore, you can attribute this to the change in separation, which is a difference also in magnitude, but not in kind. But essentially, the universal opinion before 1277 was that Aristotle is right, and we must be the only heavens and world or universe. However, after 1277, a new set of ideas and explorations appeared, and I'll start with Richard of Middleton, because he specifically connects what he's saying with the authority of Bishop Tempier. He was a Franciscan master of theology at Paris in the 13th century, and writing in his commentary on the sentences of Peter Lombard, he asserts, and I quote, "I therefore state that God could have and can still now create another universe. And to resolve the contradictions in De Coelo, he essentially places the matter of each world in its own sphere. Elements of earth in each universe are in their universes, and they come to rest naturally at the centers of their own universe. And he thinks it is possible to switch one over, and it would still be at rest in the center. But because you have nothing in between, and not only a nothing, a place where nobody can be placed, you don't run into a contradiction when you do it this way." So you can decide whether that fixes the problem with Aristotle. But from his own words, we know that he's responding to the condemnation, number 34, as I numbered it. The semantics of this start to have to be worked out, and we're in the same position here. Are we talking about other planets or other universes? What's the difference? So William of Ware, who's the master of Duns Scotus, also writing on his own questions, basically his own commentary on the sentences of Peter Lombard, he says, "By world, one can understand the universality of all creatures. Therefore, a world other than this world, once this world had been created, would not contain the universality of all creatures. Hence, it would not be another world, but a portion of our universe." So this is the kind of, you can read pages and pages of this beautiful logic that comes. We start with the premise, if we're already created and you make something else, that can't be the totality of everything, so it's part of our universe. But he said there's another way. He said you can understand by another world another celestial sphere within which would be four elements ordered in the same way as our four elements are ordered in heaven. And that's the second way in which he considers the questions of De Coelo, and also the way we consider multiverses today. We think they're, if you like, in the modern parlance, causally disconnected spaces that cannot interact. But now I'll come to a very smart guy, William of Ockham. William of Ockham is famous even in the secular world, as you know, for his razor. But his razor is really just a commonly used aphorism in scholastic writing that comes from Aristotle. In Posterior Analytics, Aristotle says, "All other things being equal, we may assume the superiority of the demonstration which derives from fewer postulates or hypotheses." So that is essentially Occam's razor in logic. More interesting, I'm going to go on a digression anyway. More interesting than that is what Jean Buridan says, because Jean Buridan takes Occam's razor and makes it into a principle of nature. He says, it's considering whether you spin the earth or the outer sphere. He says the outer sphere has to be going really fast to get around in a day. The earth would have to move much more slowly to get around in a circle in a day. And nature always prefers to do things the easier way. And this is really a precursor of the least action of Maupertuis that was mentioned before. So the beginning of least action is in the 1300s with Jean Buridan. Occam's is a heuristic. Buridan's was a law of nature he was trying to articulate. Okay, well, that's the digression. What did Occam say? Well, he says, well, first of all, it was also in a commentary on the sentences of Peter Lombard. So this is the third time. If you're wondering why are there so many commentaries on Peter Lombard, This was the main theological text in the 13th century, and every master of theology was required to write a commentary. So we're essentially reading their master's theses when we read these things, and it was part of their examination process. Ockham's commentary was not well received, to put it very mildly. He did not become a master, and he carries the title the Venerable Inceptor. If you ever hear that term, that's Ockham, because he didn't finish getting his degree. So the Venerable Inceptor directs the reader's attention away from gravity to levity, which is the word used to describe the nature of fire rising to its natural place. You can see the flames there, just below the sphere of the moon. And he says there's no contradiction. Fire is a simple substance. If we have fire at Oxford and at Paris, and I've moved them farther away here, but they're going to rise to two different places in different directions. So you can have a simple substance following its innate nature of levity move to more than one place. And if that's not a contradiction, why would the same be true for having two centers of the universe, or two universes with two separate centers? Finally, Nicole Oram, a master of arts in Paris and a contemporary of Ockham, just decides to restate the natural law of bodies entirely from Aristotle. He says they're located, quote, as far as possible in the middle of the light bodies, without setting up for them any other motionless or natural place. So this opinion doesn't require that the Earth remain motionless at the center of the universe. It allows other planets to be analogs to the Earth. And Oram's view of gravitas, which goes really back to Platonic thinking, is the one that was adopted by Nicholas of Cusa, later by Leonardo da Vinci, and then by Copernicus. And I should probably mention Bruno as well. But we have switched to William of Ware's other definition. Now we're not thinking of other worlds as universes with their own elements. We're thinking of the planets and Earth as analogs of one another within our heavenly sphere. Just about 3 more slides. So Nicholas of Cusa, who's an immediate predecessor to Copernicus, presumed that if one could leave the Earth and rise above the sphere of the fire that encircles us, you would look back and see a luminous world like the sun. Likewise, he thought if you could get through the luminous, fiery part of the sun, you would find a mass of Earth at the center. The Earth, he says, is a noble star. It possesses light, it possesses heat, and it possesses influence. He did not see the universe as consisting of concentric spheres, and to him, the outermost sphere was not a boundary. Thus, in his view, the universe is infinite. He also dared to speculate, as you see, about inhabitants of the other wandering stars in our universe. And he has some great thoughts on this. Obviously, the inhabitants of the sun are solar, bright, clear, and intellectual, while the moon's inhabitants are lunatic, quite obviously. The inhabitants of the earth are more in potency and less in actuality, and the sun the other way around, and the moon in between. And he says, really, so Karen, take heart, we believe that none of the other stars is deprived of inhabitants. This is a stamp from now disappeared country of Transkei, mentioning that he also invented the concave lens spectacle. So concave lenses are one of the 2 pieces that you need to make a Galilean telescope, and it's through his work that both pieces were laying around at the time Galileo needed them to make something. So whether or not one agrees with the central premise of Duhem, that history was changed by these condemnations, you can see throughout the medieval period a development of thoughts leading to a different view of gravity. And I'm going to end by talking very briefly about Galileo. Kepler and Galileo both adopted the Copernican view of cosmology, and Kepler extended it by proposing a universal law of gravitational attraction, which paves the way for Newton. But Galileo's success in understanding the law of falling bodies never helped him escape the Aristotelian view of gravitas. And ironically, it's because he was trying to be progressive and reject Aristotle that he embraced him so strongly, in my opinion. So here's Galileo's version of the mean speed theorem, and I could give a 10-minute digression on the plot here. That graph of the mean speed theorem, if you rotate it 90 degrees, dates back to a work from William of Heytesbury in the 14th century at Oxford, when they worked out a kind of proto-calculus that showed an accelerating body travels the same distance as one moving at its mean speed if it's a constant acceleration. Galileo employed that theorem that was already known to explain his laboratory data and thereby said gravity causes a constant acceleration of a body as it falls because his measurements fit with the mean speed theorem that had already been articulated 2 centuries before Galileo. But he completely rejects Kepler's idea of occult qualities like forces because they're too much like the exhalations and vapors of Aristotle, which are boiled off by the sun or by the moon on the Earth's waters. And so in his best-known work, The Dialogue, he essentially gives a mechanical proof for the movement of the Earth that has to ignore the details of tide data completely. And he really doesn't ever unite the work on gravity that he diligently pursued in his laboratory with what his eyes saw through the telescope. In this respect, even though he remains a central figure in our understanding of the gravitas, the weight of Aristotelian realism, he never really made the connection to the more Platonic ideas of gravity that Kepler, for instance, had as a force that rules the solar system, despite the fact that he was the first to see the moon circling Jupiter. So to close, returning to the analogy with our modern contemplation of the multiverse, what lesson can a Catholic cosmologist or historian or even white dwarf stellar astronomer take from the history that has been laid out here? And I would say we should remember the creative omnipotence of God. This idea served physics very well in the development of gravity theory, and I think with the appearance of the multiverse theories, it may do the same for us again. I thank you very much for listening, and I'll take questions.